idea that your consciousness is affecting reality not only refers to now currently in the laboratory, but 13 billion years in the past, 13 billion light years away, all over the universe. So here it is, your consciousness is supposed to affect everything throughout the universe. And that's exactly what these people are teaching. If you read what Chopra and there's other people that write with him are saying, that's what they're saying, that we're tuned into this cosmic consciousness that is all over the universe, and we're part of that. And the whole point is that this wave-particle duality thing was a total misunderstanding.
But it doesn't end there, because many propose the existence of non-local hidden variables in Leggett's inequality. However, in 2007, they were also falsified, this time by Anton Zeilinger and his team. The results sent shockwaves, and physics world went so far as to say this means quantum physics says goodbye to reality.
So recent experiments led by a group at the University of Vienna, Austria, provide the most compelling evidence yet that there is no objective reality beyond what we observe. So it's really the observation that creates the reality. And what they found is that Leggett's inequality is violated as well as Bell's. Even if you allow for instantaneous influences, quantum measurements do not fit with the idea of an objective reality. So as they say in the magazine, rather than passively observing it, we in fact create reality.
A reality independent of observation doesn't exist.
So, two things here. The first is that physicist Bernard Heisch is right. Quantum mechanics does not fit with the idea of an objective reality in that the observables or properties of quantum mechanical systems are not well defined past some uncertainty. This obviously contrasts with the macroscopic world. Heisch was not making a claim about the whole of reality itself. He was just saying that the observation is what creates the definite reality of understanding the properties of quantum mechanical systems. These properties are termed observables. This is not because they have anything to do with a conscious mind observing anything. It is because these properties are fundamentally ill-defined as shown by Heisenberg's uncertainty principle. The second thing I want people to consider is the person IP is citing. Bernard Heisch, whilst a well-respected astrophysicist, was also an editor for the Journal of Scientific Exploration magazine, a magazine which addresses, quote, topics outside the established disciplines of mainstream science, such as paranormal effects, UFOs, and cryptozoology. Heisch also has published papers in the Science and Spirit magazine, a discontinued magazine that was once funded by the Templeton Foundation that focuses on the spiritual implications of scientific findings. Here, IP cites another scientist who is entangled with Wu.
But it doesn't stop here. Prior to this in 1999, the delayed choice quantum eraser experiment was performed. If I'm going to simplify and explain this complex experiment, we need to do so with a hypothetical scenario of modifying the original double slit experiment. Instead of placing the detector at the slit, it is placed past where the particles land. But just before the particles hit the film, it is pulled away and the camera captures the results after they went through the double slit. If they observe a wave, then particles went through the double slit as a wave, and just adding a measuring device doesn't cause them to collapse to particles. But if they collapse to a state of particles at the moment of detection, then even though they went through the slit unobserved and should produce a wave pattern, the very act of observing instantly transforms them into particles. But not only that, a back history is loaded up so that particles went through the double slit instead of a wave. Well, to the dismay of materialists, the results would display particles. Observation creates the existence of particles and loads up a back history so they went through the double slit as particles. Thus it follows particles do not exist unless there is an observer.
Wrong, sir. Wrong!
Knowing which slit is not the same as knowing the path, which cannot be known because of the properties of the particles mid-flight are fundamentally inaccessible to us knowledge-wise. And it does not collapse the wave function, instead it prepares the system in a different wave function depending on the approach to measurement. During the delayed choice quantum eraser experiment, a process known as spontaneous parametric down conversion creates the two entangled photons of lower energy and frequency. This is usually done by a borate barium crystal or some other sort of nonlinear optical device. In this way, the experimenter is, in a sense, preparing the wave function with an initial condition. It can be said that the Witch path information of any quantum mechanical experiment reduces the state vector simply because the preparation of the system at any point in time of observation is such that an amount of information which would tell you one of the many eigenstates or paths of the superposition is known to be the definite state or path. Now you're probably wondering, why does it depend on the knowledge of? Well, it doesn't. It depends in principle on the knowledge of. As long as you could in principle make the measurement that gives you the knowledge of, that's where the dependence of the behavior of the particles lies. And it depends in principle on this knowledge for the simple reason that the system itself is information.
But the problems don't end there for realists. Many try to explain this away and hold to naive realism, which holds to the belief that a reality exists independent of observation, just that our perceptions are just a representation of something that is actually there, but not a perfect representation. However, this view was also falsified in 2011, this time by confirming the Cauchy-Spector theorem. The outcome of observed reality depends on the measurements at the time and cannot be predicted prior to that, which would be essential for naive realism.
The Cauchy-Spector theorem talks about properties of one system only. So we know that we cannot assume, to put it precisely, we know that it is wrong to assume that the features of a system which we observe in the measurement exist prior to the measurement. Not always, I mean in certain cases. So in a sense, what we perceive as reality now depends on our earlier decision what to measure.
While I do in fact agree, IP grossly misrepresents what the Cauchy-Spector theorem says. You have to understand that when scientists discuss quantum mechanical systems, they're discussing something that is very minute. This minuteness means that the observables of quantum mechanical systems are not measurement independent. The result of our measurements inexorably affects the value of the observable that we measure. This is known as the principle of contextuality, which is again derived from Heisenberg's uncertainty principle. Bohr pointed out the errors in the EPR hidden variable treatise, and the Cauchy-Spector theorem shows that in at least three-dimensional space, the observables of quantum mechanical systems are context-dependent, but this is insignificant on a macroscopic scale. So I don't know what IP is pointing at.
Which is a very, very deep message about the nature of reality and about our role in the universe. We are not just passive observers.
Then there was also the experiment in 2012, the non-local delayed choice quantum eraser experiment, and the results were quite astonishing. It concluded, no naive realistic picture is compatible with our results, because whether a quantum could be seen as showing particle or wave-like behavior would depend on a causally disconnected choice. It is therefore suggested to abandon such pictures altogether. Thus the conclusion is inescapable. This is why Eugene Wigner could safely say years ago that materialism is not compatible with quantum mechanics. And now with these recent experiments, we can also roll out versions of local realism and naive realism. Not only is materialism incompatible with quantum mechanics, but so is realism. As Zeilinger said, we have to give up the idea of realism to a far greater extent than most physicists believe today. Now if one wishes to just dismiss all of this, I can simply refer you to the Quantum Randy Challenge, where you can win a Nobel Prize and prove naive realism or local realism is true, and not observation dependent. Until then, to just dismiss all this science pointing in the opposite direction is nothing more than a faith-based opinion.
Something that I didn't address before is that IP is actually in a state of massive confusion regarding the implications of specific inequalities and their role in physics. You see, there is the Leggett inequality, and there is the Leggett-Garg inequality. The Leggett inequality concerns local realism in quantum mechanical systems. However, the prohibition of local realism becomes less relevant as one scales up. Often forgotten in these discussions of quantum pseudoscience is the principle of complementarity. Only on small scales is there the probabilistic component of quantum mechanics. As one scales up, the probability averages out, and you don't have to deal with these sorts of wave function outcomes when you're discussing physical systems. For example, a scanning tunneling microscope uses electron tunneling to build a 3D picture of a sample. As an individual, an electron has a certain probability of tunneling between the sample and the tip of the microscope. However, as the number of electrons increases, the tunneling probability becomes the fraction of the electrons that tunnel. Leggett-Garg inequalities are different. Leggett-Garg inequalities apply to macrostates. Now, the Leggett-Garg inequalities are violated at the Big Bang because the Big Bang is a microscopic quantum mechanical system. However, Leggett-Garg inequalities have not been demonstrated to be violated at the macro level, and many scientists, including the one who wrote my solid-state physics textbook and who is a professor at my school, have criticized experiments that would supposedly show that the Leggett-Garg inequality would be violated at the macro level.
Now, many have tried to get around this by trying to separate the quantum world from the macro world, but that was also falsified in 2010 by violations of the Leggett-Garg inequality. And in 2011, Bruckner and Koffler showed that macrorealism does emerge from quantum physics, so you cannot separate the two. This should be obvious since double-slit experiments have been performed successfully with larger things like atoms or molecules, and experiments are being devised on how to do this with mid-sized proteins and viruses, and no one doubts the results will be different. Other elements of quantum weirdness have been seen in macro objects as well, such as quantum entanglement between two aluminum chips, big enough to be seen by the naked eye, and putting a small metal paddle in a quantum superposition. So the idea that we can escape by postulating the macro world is separate from the quantum world doesn't work either.
So, in the example which IP just gave, the micro-macro distinction isn't really relevant because we're talking about something completely different. If you have ever taken a course in microelectronics or device physics, you'll learn that when the spacing between identical particles becomes comparable to the de Broglie wavelength, quantum mechanical effects become important and classical mechanics can break down. Although these experiments usually happen when those objects are supercooled to just an epsilon of a degree above absolute zero. Supercooling lowers the energy of a particular particle or object or molecule, which then increases the de Broglie wavelength, allowing for more spacing between particles. Those would be the types of situations about which IP speaks. If such experiments were done with objects like candy bracelets and toothbrushes, IP could have a point.
The macro world is built by the quantum world. Another escape route many materialists use is to hold to the many world interpretations of quantum mechanics, which basically argues there is no collapse of the wave function upon measurement, but that every possibility splits off into different worlds. So every quantum probability actually does play out. They just split off into different worlds, and in each one I'm observing each different outcome. But it is riddled with problems, unlike the idealist understanding, and it is an apparent violation of Occam's razor.
Well, I guess that's the definition of the word